This video is on solving equations that contain logarithms or exponential functions.
The first type of problem you might see is when you have a log that's equal to another log. If that's the case and they have the same base as these do, then we can ignore the logs. The reason for this is if we have the log of something equals the log of something else, those two somethings must equal each other. That's the only rational option here, is if x plus 1 is equal to 9 minus x. And then when the logs happen, they're really just doing the log of the same thing. And now we have an Algebra 1 problem where we want to get the x's on one side. So I'm going to add x to both sides. And then we want to get the numbers to the other side. And then we can solve for x, and we're going to get x equals 4. And that's our final answer for this one. Now this next problem looks similar in that we have log base 4 equals log base 4. So again, we're going to start by just setting these two parentheses equal to each other. Because again, if I'm taking the log of something equals the log of something, those somethings must equal each other. So now I've got a quadratic equation, so I'm going to try to get everything on one side, get it equal to 0. So then 0 equals x squared minus 7x minus 18. So we've got this quadratic. We want to get x by itself, but because we have an x squared and an x and a numerical term, we're going to have to try to factor this. So I want to think what multiplies to be negative 18, adds to be negative 7. That's going to be x minus 9 and x plus 2. So then I would use my zero product property, set both factors equal to 0, and then solve. So x equals 9 and x equals negative 2. But here's the issue. We might have two answers, or because we're dealing with logs, one of these might make an undefined option. So we want to relook at our problem. And if either of these answers were to give us a negative in the argument inside of the parentheses, we would have an undefined log because you can't do the log of a negative. So if we check x equals 9 for these pieces here, we'll get log of 4. 7 times 9 gives us 63, so that's 66. That's perfectly fine. And then log of 4, 9 squared is 81 minus 15 is 66. So this one actually checks out. It's not an issue. If we check x equals negative 2 in for both of these, we'll get log of 4, negative 14 plus 3 is negative 11. I see an issue. In the right side, negative 2 squared is 4 minus 15 is negative 11. So again, we have a problem because even though these are equal, log base 4 of negative 11 on both sides, we have an undefined log, which we cannot have. So in the end, x is not negative 2. We are only going to get 9 as our answer. So we can have extraneous solutions with logs because again, the log of a negative is undefined. This next type of problem is when we don't just have log equals log, but we actually have two logs and a number. If this 2 weren't here and we just had a 0, then we could maybe add this log over and you'd have log equals log, but that's not the case. So what we're going to need to do is actually use our condensing properties of logs to combine these into one thing. So remember, when you are subtracting a log from another log, that's your quotient property. So we're going to have the x plus 1 being divided by the x. And that's now going to be one log because we were subtracting two separate logs. We can combine them using the quotient rule. So now we've got a log equals a number. So this is going to be a problem where we actually have to use exponential functions. So we're going to need to convert this whole log into an exponent. So my base is going to be 8, and then I want to switch everything around. So the 2 is your exponent, and then x plus 1 over x is what that's all equal to. So now we don't have a log, and this is just an uncomfortable rational equation. So I'm going to tidy this up, call that a 64 on the left. And now I'm going to multiply both sides by x, so we can get rid of that denominator there. So we got 64x equals x plus 1. I'm going to subtract my x on both sides. So we get 63x equals 1. And this is going to be a weird little fraction, but end up with x equals 1 over 63. So our process here was, if you have two logs, but you're not equal to 0, and you can't make it log equals log, like the problem we had before, and we had to condense these two logs into one. and then convert it to an exponential equation. Now this next type of problem is when you don't actually have any logs at all, but you have an x in your exponent. So there are a couple of options. We could take the log of both sides, but that can get really weird, especially if we don't have a calculator. The other thing we want to do is think about, are the two bases the same? And if they're not, can I make them the same? So if we think about 4 as being equal to 2 squared and 8 as 2 cubed, then we can really replace the 4 and the 8. So I haven't changed the exponents on either side. I've just replaced 8 and I've replaced 4 with something that they're equal to, just in a different base. So now we do have the same base, which is great. They're both base 2. So now I'm going to distribute this exponent. And now that we have the same base, we can really think about, well, if 2 is being raised to this power, and that's equal to 2 raised to this other power, those two powers must be equal to each other. That's the only rational explanation, because we have this base of 2. And now it's an algebra 1 problem we can solve by getting x by itself and dividing. So we're going to get x equals -3/2. And since we don't have any logs, we don't have to worry about possible extraneous solutions here. So this is our one solution. The last type of problem you might see with logs and exponents is when you have your x in your exponent, but you don't have any way of making same bases. So we would start by maybe, or at least by isolating the thing with the exponent. So that's 16 to the x plus 3. Let's isolate that piece. So now we could try to think, well, 16 is 2 to the 4th, but 72 is not 2 to some power. There's like an 8 here with an 8 here, but it's not 8 raised to a power. So there's not really a whole lot we can do with that, so we have to use logs because we can't make them the same base. So if we want to convert this to a log, we start with thinking the base is 16. So I'll say log with the base of 16, and then everything else is going to switch sides. So we're taking the log of 72, and that's now equal to the x plus 3. Because when you do a log, you are finding an exponent. So we're trying to isolate that exponent by converting it to a log. So now we would just subtract 3, but keep in mind that 72 is in the log, and then you're subtracting the 3.